of this. Thank you for that. Of the spring semester. Happy New Year. So today's speaker is Dr. Parker Pennington. And so we're very excited to have her as our guest speaker and excited to hear what she's going to talk about. Everyone can put their speaker on mute just while we're getting started here and throughout the speaker series. And if you have any questions at the end, feel free to unmute yourself or ask them in the chat. And so again, we always want to recognize Campus Federal, and I think we have a Campus Federal representative here today, Ms. Roxanne. They are supporters of this program and support us every semester with putting it on. So Ms. Roxanne, did you want to say a few words about Campus Federal?
Yes, I appreciate the opportunity. As you said, I'm Roxanne with Campus Federal Credit Union. And I just want to say that Campus Federal is happy to partner with the Agricultural Student Association and the College Bag to sponsor this alumni speaker series, because this is a great opportunity for students to hear from alumni about different types of careers that are available. As a financial institution that has been serving the LSU community since 1934, so it's a long time, Campus Federal knows how important these programs are in enhancing the lives of students by providing real world experience. And I know everyone's going to enjoy today's speaker. So thank you for the opportunity to talk and enjoy.
Thank you, Roxanne. And I just want to put this up so y'all be on the lookout for it at the end of this speaker series. Following today's event, we want you to take a minute to complete a survey, and you'll do that utilizing this link. Of course, we always want to hear your feedback to better the program. Again, don't forget to complete this survey following Dr. Parker's talk. And so I'm going to introduce Mr. Colt Hardy. He is our Ag Student Association president. Mr. Colt, you want to introduce Dr. Parker today?
Sure thing. Today's alumni speaker is Dr. Parker Pennington. Dr. Pennington is a reproductive physiologist that has focused her research on non-domestic megafauna. Her research aims to adapt and implement assisted reproductive technologies to aid and improve endangered species populations. Dr. Pennington received her bachelor's and master's degrees from LSU in animal sciences with a focus on reproductive physiology. He then completed a PhD with George Mason University and the Smithsonian Conservation Biology Institute, investigating the equine uterine proteome during reproductive states, and had the opportunity to be part of the first
Przewalski's. You can just say P horse.
Przewalski's horse.
Okay, y'all heard that. Przewalski's horse. She was a part of the first Przewalski's horse foal born to artificial insemination. Most recently, she completed a postdoctoral appointment with the San Diego Zoo Global Institute for Conservation Research, working on white rhinoceros reproduction. Her work included ultrasonography. She developed an ovulation induction protocol and produced the first 2 southern white rhino cows from artificial insemination in North America. Next month, she will start a research fellowship with the Smithsonian Conservation Biology Institute, utilizing tissue culture techniques to observe uterine function in vitro. Please join me in welcoming Dr. Parker Pennington.
Thank you, Cole. So I'm going to give over the reins to you, Dr. Pennington, and then we'll all sit back and listen. So here we go.
Thank you, Colt, and everybody for inviting me to this series. I think this is a really neat idea and a great use of our virtual time that we have now, given all the COVID. So today, I guess I'll talk to you about my my career so far that I've had the great pleasure of pursuing. That all started with LSU. So I want to talk to you about conservation science and my efforts to practice it. So There we go. First, I want to talk a little bit about conservation science and conservation biology. If we think about conservation science and you're maybe want to participate in conservation in some way, but don't really feel like maybe the hard sciences speak to you as much, oh dear. There's a lot of different avenues or fields that participate in conservation that aren't that are all sort of like intertwined and interconnected with each other. Everything from ethics to public policy, climate science, anthropology, communications. If we can't communicate our message effectively, then we're not going to be able to secure funding to do the work that we need to do. That dives into philanthropy. But the area that maybe we're most familiar with and that I am most familiar with is conservation biology. And even within that sort of realm, there's many other areas that you can go with conservation biology, from the very obvious ones like genetics and population biology, and maybe some of the fields that you as ag students are familiar with, like the natural resource fields of forestries and fisheries, to things like veterinary medicine, and also things like island biogeography, which is a really interesting area of study because islands are such specialized and niche environments. We can learn from them and then sort of like apply and adapt that information. But the area that I also focus on is physiology. And there's some different areas of physiology that you can also study. But the area that I study is, like Colt mentioned, reproductive physiology. So specifically, I study the reproductive physiology of endangered species, and even more specific than that, I have tended to focus on the ungulates, and that just means the hooved animals that eat mostly grass. It includes things like bovids, equids, cervids, and then some of the less well-known ones, like, well, they're very well known, but we categorize them as ungulates, things like rhinos. Even though they don't technically have hooves, they do ruminate or ferment their food. So they still fall into that category. And where I try to exist in the area that I try to supply and promote conservation is through the adaptation and application of assisted reproductive technologies, from domestic animal reproductive management to endangered species. So we think about, for this, we use a lot of modeling. And so we model what's already known and used in the domestic field because so much has already been researched, so much is already known about cattle and horses, and even deer are becoming more and more farmed now. So they're gonna be excellent models for our endangered cervid species. But we essentially try to take what we already know in like cattle, for example, and apply it to their non-domestic counterparts like gaur and banteng. And so this goes from everything from estrus monitoring and manipulation. If we think about manipulating the estrus or the reproductive cycle to perform techniques like artificial insemination, superovulation induction protocols, if we can sort of take what's already known in the domestic world and apply it. And I say adapt because with non-domestics, you can't treat them like domestics. They are not a domestic species, and they will, you can't observe them as frequently as you do like a cow, for example. And I'll get into that a little bit as I talk about some of my work. But we also try to adapt and apply things like genetic banking. So freezing semen, for example, from genetically valuable males. We try to take cryopreservation protocols used in domestic horses and cows, apply it and see if it works for their non-domestic counterparts, because every species is a little bit different. So you start with something that's at least working in a different species and then try to see how you can tweak it. So there's endless opportunities there. And the idea behind all of it is to produce genetically healthy individuals in managed care. So our endangered species populations that exist in captivity are essentially our last genetic reservoirs hedge against extinction for their counterparts in the wild. There's not much we can necessarily do other than try to curb poaching or support the animals in the wild, but sometimes that's not enough. And so we need to produce and maintain genetically healthy populations that are sustainable in captivity so that we don't lose the species altogether. And so that once the wild is a safe place to reintroduce that species to, we have a competent population that we can draw from, that we are confident will survive once reintroduced into that natural environment. And this has been done before, so it's not like we don't have a roadmap. There's a couple of success stories that are really great, including here in the US. The black-footed ferret is an excellent example of a species that was thought to be completely extinct. One last colony was found in Wyoming, all of them brought into captivity. They were very carefully captively managed and bred, and now there are reintroduction efforts back into Wyoming. And so here in the US, we have a success story of an endangered species that was extinct in the wild and is now existing back in their native home range. Also species like Przewalski's horse that Colt mentioned in the beginning, and most recently, scimitar horned oryx have started to undergo reintroduction efforts after being extinct in the wild. And actually the IUCN still characterizes scimitar horned oryx as extinct in the wild. So the surveys haven't even caught up with the reintroduction efforts that are going on. So we have a roadmap for this, but it's very species specific. So despite knowing where you want to go with it, each species needs its own sort of like tailored plan and approach. But the end goal is to, for my part, is to create sustainable populations in captivity so that those reintroduction efforts will be successful. Sorry, it's not advancing. There we go. Okay. So I came to LSU and graduated with my bachelor's of science. So I did my undergrad with LSU and graduated in 2007. And my major was in animal, dairy, and poultry sciences, and I had a concentration in science and technology. And also I minored in psychology. But through my undergrad time, I decided I did not want to go to vet school. And I knew I did want to work with non-domestic species. I had been a keeper at Audubon Zoo the summer before my freshman year and found like, this is where I want to be. But I didn't quite know exactly where to go with that throughout my undergrad. So it wasn't until my last year as an undergrad that I took a course, and Dr. Robert Godke was teaching us the reproductive physiology aspect of it. And that's the first time, and I don't know how else to explain it other than it just like clicked. And I fell in love with the study and the field. And I found myself studying reproductive physiology instead of going to football games. And that was like, oh man, I've really lost it. But I definitely want to pursue this. So I actually approached Dr. Godke knowing that I was about to graduate and said, like, I think I want to go to grad school, but I'm not, and I'm not really sure exactly what to do, but I know I want to work with non-domestic species. And serendipitously, he had a project that had been funded but needed a grad student. And so I was able to roll right into a master's program working with non-domestic species. Oh no. So sorry, there's a lag time in the advancement. So I rolled right into a master's degree program, still with LSU, but now I got to partner and collaborate with Audubon, the Audubon Center for Research of Endangered Species, or ACRES, because that's a mouthful to say. And Dr. Godke was my advisor. And so I started studying reproductive physiology. And my thesis that we started out with was characterization of the common eland estrus cycle. And so I got to work with this pretty incredible species. They're super charismatic, and from this context, our model species was the domestic cow, or the bovid. So the idea was we need to characterize the common eland estrus cycle from both a hormonal standpoint and from an ultrasound standpoint. So there is an image of me taking a blood sample, and then also there I am in a trailer spinning the blood samples, because this was also, Acres was located on the West Bank. If you're familiar with New Orleans, the actual facility was located on the West Bank, which is interesting. And so I would process the blood samples for hormone analysis on site and then take them back to the lab at LSU. So we did get a publication out of this, but I want to point out that it wasn't necessarily on the characterization of the common eland estrus cycle. It's on the cortisol levels based on frequency of handling. And this is something that we as conservationists and also reproductive physiologists in conservation have to keep in mind when we're studying these species. Is, like I said before, you cannot handle these animals as often as you would a cow or a horse. We would take a blood sample almost every day in a domestic species. But with these, we found that there is a significant difference in the cortisol levels depending on how frequently you handle them. And those can have real reproductive impacts. So this was more of so we had to sort of like regroup, and the publication we got out of it wasn't the original intent, but because we collected samples and thought about it carefully as we progressed, then we were still able to get some very valuable information out of it. Also during my time, I made it a point to learn the technique of ultrasonography. So I was able to sort of weasel my way out onto other people's projects, and I learned ultrasonography in both horses and cows at this point. And again, it was another time that it sort of clicked with me, and I thought, like, this is a skill that I really want to utilize more in research. And so I made it a point to try to become very proficient with this skill so that I could wrap it in with other techniques. Oh, is there a way to go back? Oh, yes, thanks. So unfortunately, my graduation time from my master's was not a great economic time, as I'm sure many of you can appreciate currently, but the 2008 recession sort of hit the job market hard, but I was able to get a job with the Tulane Medical School. And so I worked in New Orleans for Tulane for a couple of years in a GMP facility, culturing and manufacturing human mesenchymal stem cells for a client or for service. So we were basically a service lab. And I also think it was a nice experience for me, knowing to step away from conservation and to step away from maybe research at the time. I'd graduated with my master's and I wasn't quite sure how exactly to continue to utilize it. There weren't many jobs. And so stepping away from conservation allowed me to make the very conscious decision to return to it, which I liked. I thought maybe I wanted to have a job where you go to work and then you go home and you can leave your job at your job. But I decided after a couple of years that I can't. So I made the very conscious decision to go back for my PhD, which really solidified that I knew what I wanted to do. And I knew I wanted to work in conservation. I wanted to work with megafauna, and I wanted to continue to develop my skill set. So for my PhD, I sought specifically Dr. Buddha Pukarenthi, who was with Smithsonian Conservation Biology Institute. I ended up citing him a lot in my master's thesis, and so I contacted him directly. And through him, he's with Smithsonian, he directed me towards George Mason to get my degree. So that's what I did. I went back to school in 2011. And my major through George Mason was actually environmental science and public policy. So I took very few hard science courses for this, but it was a nice, again, sort of like expansion of my knowledge and of the knowledge base of all that goes into conservation science. But my research was still done with Smithsonian Conservation Biology Institute. And this time I also got to collaborate with Virginia Tech, because now I was working in a different model species. I had worked with bovids for my master's, and now I also liked that I was switching to a new species. So I was going to use the equine as my model here. And my dissertation was the influence of pregnancy, metabolic status, and diet on uterine protein secretion, so the uterine proteome, in both domestic horses and endangered Przewalski's horses, or P horses for short, because that's a mouthful. And for this, I got to add new skills to my skill set as well. So I learned not only I had to manage a herd of 14 domestic mares, and I managed them through ultrasound. So I monitored them for ovulation, and then we had to take our samples, and they also needed artificial insemination so that we could recover embryos. And then I got the embryo flush technique out of it. And up there at the top, that's a day 12 equine embryo. They look like little marbles and they float, which was really neat. And that was the first for me to see. And then also we tried to replicate this study in 4 Przewalski's horse mares. So this was a point for us to be able to take the information we learned in domestic horses and see how it compares to the Przewalski's horse mares. How similar are they? And how similarly can you treat them to each other? But again, we had to sort of alter our sampling timeline because Przewalski's mares are not domestic mares. You cannot ultrasound them every day. You sort of need to like plan for a collection day and hope that it's as close as possible, and try to triangulate a way to get as close to a replicate as possible to a domestic mare. And one paper we've gotten out of this so far is the influence of metabolic status and diet on pregnant equine. So this is in a domestic horse. And I also want to point out, it's not necessarily, it's part of what we were going for, but it's not the whole thing. Turns out some of my domestic mares, I had to toss out along the way. And that's something that you'll have to do if you're working in whole animal systems. And then also in endangered species, like I said, I only had 4 Przewalski's mares in my study, and one of them never cooperated. So I never got the correct sampling time points. So now that takes me down to 3. So just being able to like collect as many samples as feasibly and ethically as possible, so that you can have others, so that you can have these sort of like extra samples to pull from when things go a little bit sideways, is always a good idea. Also, like Colt mentioned at the beginning, during my time here, I got to be a part of the team that produced the first Przewalski's horse foal artificial insemination in the world. So there's always little side things that you can get into during your studies that will really help and round out your education and your experience. So if there's opportunity for you to get involved during your degree process, in something that's not necessarily your degree, I fully support, and I think you should do it. Really round out what you get to experience while you're getting your degree. And then most recently, I've been a postdoc with San Diego Zoo at their Institute for Conservation Research, and I've been working on the Northern White Rhino initiative. And my sort of area of this massive project is assisted reproductive techniques in southern white rhinos, so developing and implementing. And to do that, and I'll just show you our very straightforward graph of what the Northern White Rhino Initiative is trying to do. So essentially, it's a very interdisciplinary project, and it's seeking to produce northern white rhino embryos in vitro. There are only 2 northern white rhinos left on the planet. Both of them are female, and so that makes the species functionally extinct. They're not going to breed and make any more. So we now need to look to cellular technologies to produce northern white rhino embryos in vitro, and then you still need to put those embryos into a surrogate. And our closest surrogate is a southern white rhino, which again is not a domestic animal. And for this species, they don't have a direct domestic counterpart, but so what we end up doing is taking the closest domestic relative phylogenetically, which in their case is the horse. So it was a nice transition for me to go from working directly with horses to working on rhinos, and it was very horse-like, just scaled way up. But the niche that I tried to occupy, or that I occupied in this project, was understanding the reproductive physiology of our intended surrogates. So San Diego Zoo imported 6 male southern white rhinos from South Africa with the express intent to research them, to learn about their reproductive physiology from them, and to eventually use them as recipients for embryos produced in vitro. Which is no small task, because to date, no embryo transfer has happened in a rhino. So there's a lot of technique development that we need to sort of, that's in the works and in the process. One of the other features that we need from these females is for them to be what we call proven. So they have proven that they can get pregnant, stay pregnant, and deliver a calf, because there's also not really an option for a C-section in a rhino. So so we need to know that they can get pregnant, and one of the other benefits is we can trial and develop other assisted reproductive technologies like artificial insemination, and that will help not only for this project for northern whites, but also for southern white rhinos that are being housed elsewhere in captivity across the country. So to do this, like I said, San Diego imported 6 female southern white rhinos. But when they came to us, we found out through hormones that they were not ovulating. So this line, this graph is progesterone values from all the females. Well, 5 of the females were not ovulating. 1 decided to ovulate on her own because she's special. But we had this data, this hormone data, and also these were fecal samples that were collected. So it's a nice non-invasive way to monitor the ovulatory status of these animals, but it's also retrospective. It takes quite a while to process fecal samples. And then you're sort of like looking into the past to see if they're ovulating, but we, 1, aren't seeing things in real time, and 2, this doesn't really give us any information on what's happening on their ovaries. Are they not ovulating because their ovaries are completely inactive, or like what's going on? So once they were trained for regular ultrasonography, we found that they were in fact growing follicles, which is the structure on the ovary that houses the egg, and when it ruptures, that is ovulation and makes an egg available for fertilization. So we found through ultrasounding their ovaries that they were in fact growing follicles, they just weren't ovulating them. And that's not really going to work for the Northern White Rhino Initiative, because if you don't ovulate, you can't get pregnant. So from several standpoints, this was not a great situation, but we were able to routinely ultrasound these females without sedation. And also this work got us a publication that other managers can now use if this is a situation that they're experiencing with their animals as well, because this anovulatory status of white rhino females in captivity is quite common. So this is, 1, it's going to help us in our project, and 2, it's going to help the rest of the population. So after we established the ovulation induction protocol, we started layering on artificial insemination. And so the top left is just post-insemination using ultrasound to confirm semen placement in the uterus, because we knew we wanted to get it across the cervix and actually deposit semen into the uterus. And so the ultrasound helped us confirm that that's in fact where it was. And then the picture on the bottom left is a day 18 rhino embryo, which we knew when she ovulated because we gave her the protocol. We knew when she was fertilized because we inseminated her. And so we know exactly how old this embryo is. And it actually looks very similar to an equine embryo at a similar stage. And the picture on the right is the face you make when you find it. because I was not expecting to find it. And the keepers were telling me to hurry up because they had other stuff to do. And I was like, yeah, that's fine. And then I saw it and then I had a little freak out. Eventually they grew. Okay, so because we knew how old they were exactly, we were able to track them with ultrasound as well and generate some of the first images of fetal growth and development in utero. So this middle one you see here was a foot. While they were swimming around, they were actually quite active. And it really depended on the day, the view you got. So was also a fun surprise every time. Over here on the right, you can see just how horse-like the species is. That's a calf in profile, but they still look very horse-like. And then this one over here on the left, it's hard to see. In the middle bottom is the heartbeat. So within the rib cage, we caught the heartbeat of the fetus. And so this is some of the first data about like fetal heart rate in utero and fetal growth rates in utero. This by no means sets a standard. It's only 2 individuals, but it's a start. And since we know exactly how old these calves were, we know we can start generating this information. So like I said, these are the first 2 southern white rhino calves born from AI or artificial insemination in North America. And I want to make that distinction both in species. I want to distinguish that these are southern white rhino calves because I want to give credit to my colleagues in the field as well. There's a scientist, Dr. Monica Stoops, that has been working in greater one-horned rhinos and has developed or has produced some calves from AI in that species. So, and then also these are the first in North America. Europe produced 2 calves, I believe, before we did, but these are the first 2 on North American soil, Edward and Future, and they are at the San Diego Zoo Safari Park, and both are over 1 year old now, which is wild that they're that old, but they got excellent birthday parties, so that was exciting. My next steps that I'm hopefully starting soon, like next week. I'm back at Smithsonian Conservation Biology Institute, back working with Dr. Pukazenti. And what I'll be doing is going back to sort of the equid world and working on equine endometrial organoids. And the idea behind this 3D cell culture technique is you can essentially model the organ function in vitro. So if the donor tissue type was kidney or liver, it's going to model that morphology and physiology in vitro. And so for this, we're going to model uterine function in vitro. And the aspect that I'm taking on is obesity. So sort of hearkening back to my PhD work, how does obesity and its associated metabolic dysfunctions impact the uterine environment? And this is a way to study that function without one needing to maintain a whole mare in an obese state, which is an improvement on animal welfare. And it also lets us trial some therapies. It also lets us, again, model for our endangered species, 2 of which are housed here at SCBI, Przewalski's horses and zebras. And this is also a poignant study because obesity is also a problem in our domestic animals in captivity. And obesity is associated with subfertility. Subfertility in an endangered species is obviously not good when we're trying to maintain healthy genetic progeny and offspring. And so this has several implications, but the angle that I'm always trying to take is how do we maintain and improve endangered species welfare and reproductive potential. So with that, I just want to say, like, it's been a wild ride for my career and my education so far, but any advice I have is to constantly be trying to gain, develop, expand your skill set. So I've made a point of becoming proficient in ultrasound and working in whole animal systems. And now I'm sort of switching gears and going into a 3D culture system. And I'll still get to work with the animals, with the whole animals, but it's going to be a really valuable addition to my skill set to develop this organoid tissue work. And the more well-rounded skill set you have, the more valuable you are as a candidate. And then also be flexible. If you'll notice, both my master's and PhD publications were not necessarily the original intent of my thesis and dissertation, especially when working with whole animals, and especially when working with endangered species. You might not get enough samples to look at the thing that you intended to look at. And so find a way to still make the data valuable. There's always information, and information is always valuable. So there's a way to get something out of it, even if it wasn't your original intent. And then the people that you know and meet and are interacting with now, from your professors to your classmates to like professionals in the field, life moves in circles. And you're probably going to either work with them, for them, or they might be working for you in the future. So maintaining and developing those good relationships, I think, is really important, especially now at this point in your careers as undergraduates. You know, you've just started. So all these people are potentially poised to help you advance your career. And there's so much you have to learn from them. There's so many people available to help you. So don't be afraid to ask for that advice and for that help and for that experience. See if you can get, if you're interested, just see if you can get in a lab and decide that you either do or don't like a particular thing. That's just as important, knowing what you don't want to do as knowing what you do want to do. So with that, I just also want to say, have fun. If you're going to go grad school and you're going to go the academic route, it's not always going to be fun. It's hard, and you're going to maybe question your life choices a little bit, but try to have fun and know that in the end, it's going to be worth it, and find the ways to make it enjoyable. So with that, does anyone have any questions?
Y'all can unmute your microphones if you had a question, or drop it in the chat. I have one if no one's going to go. Dr. Pennington, at the beginning, and you might not be able to answer this, but at the beginning you mentioned in the realm of conservation, it's not just science, you also need communicators. Can you maybe speak to in what capacity someone who's maybe not interested or doesn't want to go the hard science route, but wants to go the communication route, like how does that interface with the work that you do in a real world setting?
Oh, I mean, there are entire PR departments for most zoos and most, at least large conservation organizations. So at San Diego Zoo, we had to, we got to interface a lot with our PR and development people that would field and set up interviews with like local newspapers. They would help draft communications and press releases for the work that the scientists were doing. There's a real talent and skill to being able to convey and communicate science. And also, you know, in the realm of conservation, it can get a little touchy quickly. And so the ability to communicate that as well. So there's definitely PR departments, and it goes across the board, from very technical like science writers to like popular press publications.
Thank you. I think can you view the chat, or would you prefer for me to read them?
I can read it. Okay. Let's see. Oh yeah. So I interned at the zoo in New Orleans. How would undergraduate students pursue options like this? Are there particular people to contact? My internship as a zookeeper at the zoo, I think that was, I met somebody that worked at the zoo, so I directly contacted them, but there are definitely internship opportunities that you can go visit the web zoo. Post a lot of times they're intern opportunities. Most zoos and like conservation organizations will have an internship. San Diego Zoo has a fellowship, a summer fellowship opportunity every year. And you can work in anything from like reproductive sciences to genetics to the ecology department. So you could be like out working with burrowing owls or like in the lab with reproductive physiology. I would suggest a lot of times they post either on their own website, which is sort of a cumbersome way to go about it. But like I know Memphis Zoo has internship opportunities. If you go to aza.org, most of them are summer opportunities. So that's the best time to look, but go to aza.org and a lot of institutions will post their internship opportunities there as well under careers, and you can actually like filter out intern opportunities.
Yeah, I just add to that. I think it was several years ago, I was at the aza.org site about internships, and there were probably 20 or 25 of them, including 7 or 8 at New Orleans. So that's where you should really start.
Let's see. Which is the next one? Has everyone I worked with on major projects had advanced degrees? Not necessarily. So all of my projects working with endangered species necessarily involve keeper staff, so the actual animal care staff, and they don't necessarily have advanced degrees. Some have had master's degrees, but you don't necessarily need one as an animal caretaker. So from that perspective, also like in the lab, like lab managers, some of the lab managers I've gotten to work with don't have advanced degrees. They do have their bachelor's, but they don't necessarily have their master's or PhD. So not necessarily, depending, I think it really depends on how you want to be involved. But there are definitely ways to be involved without an advanced degree. Talk about specific skills that helped you navigate such a complex career. Well, personal skills, like I sort of mentioned at the end, is networking and collaboration. A lot, especially in conservation, relies on collaboration because zoos can only hold a handful of a given species, a handful of individuals of a given species. So you need to collaborate with a lot of institutions in order to get enough samples or get enough work done. You also need to know what the issues are and what the zoos are sort of wanting, what kind of information they need in their population to better manage their population. So collaboration is always a good skill to have, like across the board. That's not that's never a bad skill to have. Educational, like I said, expand your skill set, get involved, and become comfortable out of your comfort zone. Learning a new skill is never fun. You're not going to be good at it at the beginning. And so understanding and knowing and having that confidence in yourself that, okay, it's not great now, but I'm going to get better at it, and having that sort of perseverance to work through the skill and work through the process. And even if you decide you don't like it or decide that you don't want to use it, understanding that like that's okay. If you decide you don't want to work in that particular area. If you don't like this skill and don't, if you never use it again, that's too soon. That was my whole, I enjoyed going to New Orleans and working for Tulane. It was a nice sort of like step away for me. And I think it really solidified in me knowing that I wanted to work in conservation and knowing that how exactly I wanted to work in conservation. But I hope that answers your question. I think networking and knowing as many people as possible. It's going to be a small field, especially in conservation. It's a really small field, so you'll know everybody pretty quickly. But it's always fun to sort of like expand that personal area of your skill set. How did I make the decision to stop pursuing vet school? Oh, after working as a keeper at Audubon was the first time I had not worked for a vet clinic. So all throughout high school during the summers, I worked for vet clinics because I, again, thought that was the direction I wanted to go. And so I worked for a small animal clinic and thought like, okay, that was neat, but not for me. And then I worked for a large animal clinic and was like, all right, more my lane. I like the big animals, but not necessarily what I want to do. And then I worked for Audubon. And that's one where it clicked for me that I wanted to work with non-domestics, and two, that I didn't necessarily only want to see the animal when it was sick. And I didn't necessarily only want to interact with that animal one time and then it goes away and then maybe I don't see it ever again. So that's sort of where my thought process was with vet school. I still sort of kept it as an option throughout undergrad, but ultimately decided against it. And that's another thing I'll say, don't count anything out like if you're not sure, don't count it out. I wanted to keep vet school as like a thing that I could apply to if I wanted to. So I still took as many classes as I could that were prereqs for vet school, but ultimately decided to go a different direction, especially once I took that class with Dr. Godke. It was just like, oh my God, this though. So. Do you believe that there is a job market for reproductive specialists in domestic livestock production? This was one of my first career interests, being raised around livestock. However, was led to believe that the opportunities were extremely limited before coming to college. I mean, yes, there's definitely a job market, depending on how you want to be involved. And Dr. Bondiola, you might be able to speak more to this, especially in the domestic field. I think it might be more in vitro focused, but there's definitely, I do think there's a job market. It might also be small. I'm not as familiar with it, to be perfectly honest.
Well, I would say that right now there's a growing opportunity with the in vitro embryo production because the people involved in the embryo transfer are tripping over themselves, trying to establish labs to do in vitro fertilization and create embryos. You can also find the thing is you can get the same sort of opportunities in the human IVF. The human IVF labs pay more. That's all you can say. There's no doubt about that. Anything doing with domestic animals in that realm will not pay like the medical sciences do. But right now, there's a real growing opportunity if someone wanted to pursue that with domestic animals. And that can, while say a graduate or master's degree would help you on that, that could also be pursued without a graduate degree.
Thanks, Doc.
Okay, well, I think that concludes our speaker series with Dr. Pennington. Again, thank you, Dr. Pennington, for taking time today to kind of inform us, expand our knowledge, educate us on reproductive physiology and, your experience thus far, which is so much experience and so you're early on in your career. So I look forward to seeing where you go. It's exciting. So
Thanks.
again. And this we want you to mark your calendars for our next speaker coming up. Is Mr. Ken West. He is a nutrition grad, a nutrition and food science grad, and so he's the CEO for the Regional Medical Center in San Jose. And so mark your calendars for February 26th. He'll be speaking to our students then. And then following him in March, we'll have Dr. D.Q. Fields, who's the Dean and Senior Associate VP of the Dale Bumpers College of Agriculture, Food, and Life Sciences at the University of Arkansas. So if you haven't already, put these on your calendars and plan to attend. We have some great speakers coming up as well. And then Dr. Martin's gonna about Ag Week. This is the schedule thus far, but I know Dr. Martin, you can expand on it.
Yeah, just real quick, we wanted you to be aware that Ag Student Association is working on the Ag Week schedule, and Colt is in the process of submitting paperwork with EOC so we can get our events approved. And then we are again working with Southern University and their college to host these events. So you'll see things that will have virtual collaborations between the two campuses throughout the week. And so we have a mix of both in-person and virtual events. Miss Ashley, Miss Lindsay have two really great events that I want you to make sure you have marked on here. And that's that virtual collaboration on March 16th, which is a speed networking event. And so you have the opportunity to network with alumni and leaders within the agriculture industries. And then on Thursday, there's options for both a law school panel and a vet school panel. So that way you can connect with those institutions with both LSU, and then on the law school side, we'll have both Southern University and LSU involved in that. But it's just a great way for you to continue planning on your professional development during your time with us in your undergrad experience. And then there's some fun events that are sprinkled in here as well. So look for more information in the coming weeks on Ag Week 2021.
Thank you, Dr. Martin. And again, we mentioned this at the beginning of class, and Ms. Grant's going to put it in the chat. Before, please take a few minutes to complete the survey. It's really short. It shouldn't even take you a few minutes. But here's the link to complete it. And so before going about your day today, take time to complete the survey. And go Tigers. Thank you again for joining us. We hope you enjoyed Dr. Pennington's presentation as much as I did and we did. And so again, we look forward to having you at the next speaker series. Thank you guys.